Okay, so let's look at number 8. We want to find the vertex, the focal length, and the coordinates of the focus, which probably is somewhere around here, because remember the focus is like interpreting like that light bulb on a flashlight that will shine light no matter what angle it hits the parabola at, shine it straight out. Okay? And the focal length is basically just what is the length between the focus and the vertex. Okay? And which is, of course, the same as the length from the vertex to the directrix, if you were asked that. And then the vertex, finally, it's highlighted in gray, would be this point right here, the vertex of that parabola. Okay, so this is the horizontal piece here. We're going to find the missing information, basically just from this piece. Now, whenever we're looking at parabolas, we usually get y by itself. But if it's a horizontal parabola, we're going to get x by itself. So I want to first change this by adding this 2 to the right side. Okay, I'm going to move this across this equal sign so that x is now all by itself, and I have something that looks like this. Okay, so I just moved that 2 over by adding it to the right side. Now the vertex, I can look at this form and know that anything in parentheses is going to be interpreted as the opposite. So y is really 3. And then anything on the outside, since it's x all by itself, this right here is going to be interpreted as what you see. So with x being 2 and y being 3, my vertex is 2, 3. Okay? It's just reinforcing that idea that anything in parentheses is opposite and anything on the outside is what you see. Just remember, because you got x by itself, don't think that this is going to be an x value of 3. Okay, so it's not. It belongs with the y, so that's why it's the y value. And whatever this is must be the x value. Okay, focal length. So 4 AP classes is equal to 1 tough year. We got this, and we use this to find this focal length. Now we've been working with ellipses and parabolas where the focal length is usually with the letter C, but with parabolas we're using P. Okay? So P is what we're looking for. And if you remember and recall from the standard form of this equation, it's x is equal to a y minus k squared plus h. Okay? This right here is the standard form for the horizontal parabola. And because we see right here that I have an a value of -1/2, I can go ahead and plug that in over here for a. So we'll put -1/2 times 4 times p is equal to 1. Well, -4 times 1/2 becomes -2. So we have -2p is equal to 1. Therefore, p is -1/2. So we have a focal length of -1/2. So that means from this coordinate, or the coordinate of the focus, will say it's going to have a focal length of 1/2. Okay? So as far as this focal length is concerned, like if you put, the reason why you want a negative per se is because it's facing to the left. But if I were to ask you, how long is this? You would just say it's 1/2 units long. Okay? But the reason why I want to make it a negative is because I'm actually going to use that to add with whatever the vertex is. We know that this vertex was in fact 2, 3. So if I'm adding an x value, okay, to that 2, I'm adding a focal length of -1/2. It's the same as adding a negative is the same as just subtracting. We're going to be able to see what it is that we get as far as how much is it going to move to the left. So 2 minus 1/2 is 1.5. Okay? And your coordinates of the focus would be 1.5, 3. So some of you might put 1.5. Otherwise, 2 times 1 plus 1 is 3/2. So if you put 3/2, 3, I would still accept it. If you put 1.5, 3, I would still accept it. But probably the way we're looking at it, as far as a graph and being able to quickly identify, I think that 1.53 would be the better choice. Okay. Now, I know it's not asking, but if it did ask what is the equation for the directrix, that's this x equals a number, vertical line here. We know this jump was 1/2. So if I jumped 1/2 to the right, it would be, instead of subtracting from 2, I'm going to add to 2. So 2 plus this 0.5 that we got would show that it'd be x is equal to 2.5. And that's what the equation would be here to show that vertical line for the directrix.